A database management system's lowest level of software is Disk Space Manager. Disk Manager hides the details of hardware and OS involved in working with disk from the database management system. The unit of data management at Disk Manager level is a page. The higher levels of software can think of data as a collection of pages. Disk Manager handles allocation and deallocation of pages, reads, writes, and handling the available space on disk. To do that, it needs to keep track of block usage within the disk. This can be done using a list of free blocks. Free blocks within a disk. When blocks are deallocated, they can be added to the list of free ones. An alternative way is to maintain a bitmap with one bit for each block, which is set when the block is in use and unset when not. Using the bitmap, it is also easy to find out the contiguous available space. This is not that easy using the list method. Database management systems can use some functionalities of OS file system to perform the disk management. However, most of the database management systems perform their own disk management. One reason for this is that the database management systems may want to stay platform independent and stay away from OS-specific features. It also has to do with finer control on prefetching, buffer replacement, and scheduling. This is to perform them in a more specialized way for database records. For example, the virtual memory in operating system has similarities to database management system's buffer management. Both of them try to bring pages from disk to main memory when necessary and write them back to disk after. They both try to minimize the number of moves back and forth involved. They try to achieve this by efficient management of transferred and in-use pages and available space. The patterns of working with pages of data might be better known to the database management system. Therefore, it prefers to have control over these functions so that it can optimize the operations using this additional knowledge. For example, a buffer management might be able to predict page usage patterns based on higher level operations and prefetch pages before they are requested by predicting that they will be used. This can make the data available faster by making the pages available before they are requested. Another way this can help is by changing the pattern of random access to sequential access to the disk. If the database management system recognizes future data usage needs the pages in between. This will effectively improve the performance of a database management system. Buffer Manager is an important part of a database management system. It manages bringing pages from disk to memory as they are needed by the database management system. Buffer Manager manages the main memory by partitioning it into a collection of pages, which we call buffer pool. Higher levels of database management system code can be written without buffer management details, and only asking for the needed page and releasing it when they're done with it. Buffer Manager can perform this using the help of two variables, dirty and pin count. Dirty indicates whether the page has been modified since it's brought from the disk to the memory pool. This is to make sure the changes are written back into the disk. Pin count keeps the number of times the current page has been requested but is still not released. It starts from 0 and is increased for each page on request and decreased on release. Say your database has stored 1 million pages, but main memory has capacity for holding only 1,000 pages of data. If you have a query that requires to scan the whole database, what would you do? All the 1 million records cannot be brought into the main memory at the same time. The database management system needs to bring the pages in the memory gradually so that it can facilitate that scan. It needs to decide which pages to move out to make a space to bring in the new pages. The policy used to decide which pages can be replaced is called replacement policy. Different replacement policies can be used by the database management system. Least recently used and clock replacement are among the famous ones. First in, first out, most recently used, and random are also among the different replacement policies. LRU stands for least recently used. In LRU, a queue of pointers is used to point to the queues with pin count of 0. Pages are added to this queue when they are completely released. Being released means they have the pin count of 0. When the page reaches the head of this queue, it is replaced. A question that comes up is that why don't we replace the page as soon as its pin count becomes 0? One of the goals of the replacement policy is to minimize the moves from the disk to buffer to the main memory and back. The replacement strategy tries to come up with a combination that minimizes unnecessary transfers. This also counts for transfers that might be avoided by keeping a page that might be requested again. And that is the reason to our question. Clock replacement is similar to LRU, but it has two additional variables called current and referenced. Current can hold values between 1 to n. N is the number of the buffer's available frames, meaning the number of pages to fit within the buffer. Referenced is a bit. It is turned on when the pin count goes to 0 for a page. In clock replacement, current circles from 1 to n like a clock movement. If pin count is not 0, the page is not a candidate for a replacement. If pin count is 0 and reference is set, clock replacement only unsets the referenced. If pin count is 0 and reference bit is unset, clock replacement chooses the frame as a candidate for replacement. As you may tell from the procedure, the reference bit is used to reduce the possibility of replacement of a recently referenced page. This is to consider the possibilities of reducing unnecessary data transfers. None of the LRU and clock replacement are always effective. For example, consider a database with the number of pages only a few pages more than the available in the buffer. If we need to scan this database sequentially, the replacement policies discussed will result in reading every page of the file for each scan. This is called sequential flooding.